Hello students, we today start that nuclear reactions, that is nuclear transmutation reactions. See here, what is nuclear reactions? Definition. Nuclear reactions are the processes in which a nucleus reacts with another nucleus. Nucleus react with another nucleus, proton or any other projectile in a very short time to produce one or more new nuclei. See here, the processes or the process in which one nucleus react with another nucleus, one nucleus react with another nucleus in a very short period of time and to produce new one or more nuclei. This process is known as these processes are known as nuclear reactions. Nuclear reactions. Only remember, nuclear reactions are nothing but one nucleus react with another nucleus in a very short period of time to produce new nuclei. This process is known as nuclear reaction. Then nuclear reactions are classified into different categories as nuclear transmutation, then nuclear stripping and pickup, nuclear spallation, nuclear fission, nuclear fragmentation, and nuclear scattering reactions. These are 6 different categories of nuclear reactions. We discuss here first nuclear transmutation reactions. In nuclear transmutation reaction, one nucleus reacts with another nucleus and produces new nuclei. This is about that nuclear transmutation. Then in nuclear transmutation reactions, the 2 rules strictly obeyed. First rule is conservation of charge. That is, total charge on right hand side must be equal to the total charge on left hand side. That is, total charge of reactant must be equal to the total charge of product. That reactant side is said here left side and product side is right side. We can say this as the total charge on right side must be equal to total charge on left side. This one is first rule. Second rule is conservation of nucleons. Conservation of nucleons. That is, total number of nucleons on the right hand side must be equal to total number of nucleons on the left hand side. What are nucleons? That is, number of protons plus neutrons. Protons, neutrons and electrons also. That together known as nucleons. That protons, mainly protons and neutrons. Number of that nucleons on product side must be equal to number of protons and neutrons on a reactant side. See here, for example, by applying these 2 rules of nuclear transmutation reaction is shown here. That is nitrogen 714, which is one nucleus bombarded with or react with another nucleus, that is helium 24 as a projectile. That one is known as projectile. And that nitrogen, which is as a substrate nucleus, that one is known as target. That one is bombarded with projectile. Target is bombarded with projectile. and during that bombardment, that two nuclei, that is nitrogen and helium nuclei, react together to produce new nucleus, that is oxygen 817, that is newly generated nucleus, which is known as recoil nucleus. Recoil nucleus, and with that recoil nucleus, another small particle also generated in this reaction, that is proton H11, proton, that is H11, which is also known as ejectile. That small particle generated is known as ejectile. See here, what is target, what is projectile, what is recoil nucleus, and what is ejectile. See here in this reaction. In this reaction, about two laws are strictly obeyed, that is charge and nucleons on both sides are same here. See here, charge here for nitrogen 7 and helium 2. At the reactant side, 7 plus 2, 9. And at product side, see here charge 8 plus 1, 9 is there. Means 9, 9 is same. See here nucleons, number of nucleons, that is mass number. Proton plus neutron, that is number of nucleons on both sides also same. See here, for nitrogen 14. 7 protons, 7 neutrons, 14. For helium 4, 14 plus 4, 18. That become here on product sides here 17 plus 1, that is 18. 18, 18 both side. This is rule for this nuclear transmutation reaction, that is charge as well as number of nucleons on both side must be same, that is reactant side and product side. Then what is target? In this reaction, what is target? It is the nucleus which is bombarded with the projectile. Then what is projectile? Which is highly energetic particle used to bombard the target nucleus, which is known as projectile. Then what is recoil nucleus? The nucleus formed in the process of transmutation is known as recoil nucleus. See here oxygen 817, which one is generated, which is known as recoil nucleus. That is nucleus generated or formed in the process of transmutation is known as recoil nucleus. Then what is ejectile? Ejectile is a small particle formed in the nuclear transmutation reaction. Then theories of this nuclear transmutation reactions. There are two theories. First one is compound nucleus theory. Compound nucleus theory. That is, theory means any judgment or principle which is useful to explain that nuclear transmutation reaction. With the help of that theory or theorem, we can explain that process of nuclear transmutation. There are two theories out of that. First is compound nucleus theory, which is also known as mechanism of nuclear transmutation. We explain with the help of compound nucleus theory. Then according to this theory, the nuclear transmutation reaction takes place in two steps. Nuclear transmutation reaction takes place in two steps. In first step, projectile is bombarded, the projectile, when bombarded, that projectile is absorbed by target. Projectile which one is bombarded on target, that projectile is absorbed by target. Target is large nucleus, projectile is small particle nucleus. That one is absorbed by that target nucleus, and that combine to form compound nucleus. Compound nucleus is a more energetic nucleus, because that when absorbed, that target when absorb that projectile is highly energetic. Therefore that energy is absorbed, or that uh, pro- projectile with their energy, that target absorb that energy also, and therefore energy of that compound nucleus is very high. That is, this is first step. Projectile is absorbed by target is first step. Projectile is absorbed by target, and that target is converted into new nucleus, which is known as compound nucleus, which is highly energetic nucleus. Then second step, the compound nucleus, which is highly energetic nucleus, then decay to another nucleus, compound nucleus, then converted into another new nucleus with emission of another particles, with emission of small particles. The mode of decay of compound nucleus depends on energy of that compound nucleus. Energy of that compound nucleus. That means these are two steps. In short, first step is projectile is absorbed by target, and convert that target is converted into new nucleus, which one is known as compound nucleus, which one is highly energetic nucleus. This is first step. Second, that compound nucleus then decay in or converted into new nucleus, new nuclei. That process is nuclear transmutation. And that decay method, there are different modes of decay of that compound nucleus, and that mode of decay depends on energy of that compound nucleus. For example, here this nuclear transmutation reaction we explain with the help of this compound nucleus theory. For that purpose, consider one example: nitrogen, which is one is target here, 714, bombarded with alpha particle, that is helium-24, that generate compound nucleus, which one is very unstable. Why very unstable? Because highly energetic, and we know that any highly energetic species is unstable, and that converted into new unstable, and that converted into new nuclei. See here, that target absorb that alpha particle, which is a highly energetic. Actually, projectile is highly energetic, and because that highly energetic projectile absorbed by that nitrogen, then that nitrogen is converted into intermediate compound nucleus, which is very unstable, very highly energetic, and that compound nucleus decay in different uh, different ways. First way is that compound nucleus, that is fluorine 918, is converted into fluorine 918 with loss of gamma radiations. That one is highly energetic. Energy only loss of energy takes place in the form of emission of gamma radiations, and that in charge and number of nucleons remains as it is. That is here also 918, here also 918. Then what is the loss? Energy only, emission of energy takes place in the form of gamma radiations. Then second way is that compound nucleus, that is fluorine 918, may converted into fluorine 917 with loss of one neutron, highly energetic neutron, that is 0 1. Then another way, that may converted into oxygen 817 with loss of proton, that is H11. By another way, that may converted into oxygen 816 with loss of hydrogen 1 2, that is deuterium, which is isotope of hydrogen. Then another method that may converted. Then we discuss examples of that projectiles, that is examples of different nuclear transmutation reactions using different type of projectiles. That is, in above example, alpha particle is used as a projectile. Then instead of alpha particle, we can use proton, we can use neutron or deuteron as a projectiles. We explain the different nuclear transmutation reactions using different type of projectiles. First example is nuclear transmutation reaction using alpha particle as a projectile. Using alpha particle as a projectile. Okay, thank you. We discuss afterward.